Dear students, in this class we are going to prove that in an integral domain there is no non-zero nilpotent element. In other words, 0 is the only nilpotent element in an integral domain. Now, in order to prove this, definitely we will need the definition of integral domain. So what exactly integral domain is? Integral domain is a commutative ring with unity without zero divisors. Now everybody knows what exactly commutative ring with unity is, but the problem is without zero divisors. So the main question is, what do you mean by ring without zero divisors? And the condition is, if you take any two elements of the ring R such that AB is equal to 0, then this should imply A is equal to 0 or B is equal to 0. If this condition is satisfied by any two elements of the ring R, then we will say that the ring is without zero divisors. Now remember that this definition doesn't work only for two elements, but it also works even if we are having any number of elements here. Like if we have A, B, C is equal to 0, then it implies A is equal to 0 or B is equal to 0 or C is equal to 0. Same idea can be extended if we have four elements A, B, C, D equal to 0 and so on. Now it is already given to us R is integral domain. It means that ring is without zero divisors, and A belongs to R is a nilpotent element. Now what is the definition of nilpotent element? Some positive integral power of A is actually equal to 0, and that is exactly what I have written here. Now remember, what do we mean by A raised to n in ring theory? A raised to n means A multiplied by A multiplied by A n times. Therefore, this implies that A multiplied by A multiplied by A and so on is equal to 0. Remember, this is n times. But ring is an integral domain. It means that it is without zero divisors. So therefore, what will happen? Such type of condition will be satisfied, and therefore it will imply A is equal to 0 or A is equal to 0 or A is equal to 0. This will be continued, and this will be how many number of times? N times. Now remember, we are having OR between these n statements. So at least one statement is going to be true. Whichever may be true doesn't matter to us. In any case, what is going to happen? A is going to be equal to 0. So what we have proved in this example? We have proved that if you take a nilpotent element in an integral domain, it must be equal to 0. In other words, integral domain has no non-zero nilpotent element.